Okay, students, this is your well-rounded math teacher, Mr. Picard. We're on Unit 9 here, and Video 1, Notes Video 1, we're going to be multiplying and dividing rational expressions. Our learning targets are you can simplify rational expressions, and I can simplify complex fractions. So a couple different things there. So we got a word problem here we're going to start out with, kind of explaining what rational expressions are. First of all, rational expression is, when you think rational numbers, you think fractions. Something written as a fraction, like 1/2 is a rational number. A rational expression is something maybe where you're working with variables. Okay? So, rational expression or a ratio of two things, like the ratio of 1 to 2. Here we'd have the ratio or rational expression of x to x plus 2. So that's what we're talking about when we're talking about rational expressions. So first of all, rational expression ratio of two polynomial expressions. It's basically written as a fraction. They also call it a ratio. Here's the numerator, here's the denominator, and here's your fraction bar. This is a ratio, or what we call a rational expression. We're going to be multiplying rational expressions. Basically, you multiply straight across. So we're multiplying these two ratios, or these two rational expressions. This would become 5x times x minus 2. Multiply the tops, the numerators, and multiply the denominators. X plus 1 times x minus 1. And then you'd go from there. A couple different things we can do with them. When dividing rational expressions, okay, when you guys have done it in the past, like we'll say 1/2 divided by, we'll say 3/4. Well, you don't actually divide, you multiply by the reciprocal, or multiply whatever you're dividing by, it's reciprocal. So this would be 1/2, you don't change that, and you multiply by the reciprocal of what you're dividing by, and that'd be 4/3, or 8 over 2 times 3 is 6, and you can reduce that down to 4/3. So you multiply by the reciprocal when you divide. Flip the bottom fraction and then multiply. Or flip the fraction that you're dividing by. Okay, so for this particular problem, it's actually x over x minus 1 times, we're dividing by this part, this ratio or fraction. So x minus 1 would go on top, and 3x plus 2 would go on bottom. So it's x times x minus 1 all over x minus 1 times 3x plus 2. And you can simplify it from there. Keys to success here. When you're simplifying these fractions, whether that's just a ratio that you're simplifying, or a multiplication problem, or a division problem, factor everything you can. A lot of things you won't be able to factor, but some you can. Simplify, that means cancel things out when you can. Perform the operation, the multiplication, division, whatever it is. And then once you get your answer, you should factor it and simplify it again. So let's look into these a little bit. Here's our keys to success. We'll move those off for a second. Now, this is a multiplication problem. That's the first thing you should figure out right away. We are multiplying these two. So I'm going to multiply the numerators, so I'm going to multiply the denominators. To make it a little bit simpler, you might want to reduce it. Like numerator to denominator, or denominator to numerator. Here I have a 5, here I have a 15. Before I multiply, I can reduce this. 5 goes into 5 once, 5 goes into 15 3 times. Also, the 16 and the 4, I can reduce that, simplify that a little bit. 4 goes into 4 once, and 4 goes into 16 4 times. Now, just looking at what we have here, get rid of those circles. Now I have the 1 times 3, or 3, and then I'm also multiplying the a and the b squared. So I'm going to say a b squared all over. Here I have 1 times 4, multiplying the numbers first. And then the variables, I have a b and an a cubed. I'll put your a first, kind of keep in alphabetical order. A cubed, and then a b. The number part of it, the fraction, or I'm sorry, the coefficients, the numbers in front of the variables. 3/4, I can't reduce that anymore. So I'm going to leave that as 3 over 4. Now the a's, you're not going to have more than one a term in any problem when it's simplified. When you're looking at ratios, I have one a in the numerator and an a cubed, a times a times a in the denominator. When we're dividing, what do we do with the exponents? We subtract. We'll have more a's in the bottom, so this is actually 3 minus 1, or 2, a squared, but meaning we have more of them in the denominator, it's going to stay a squared in the denominator. Where do we have more b's? Well, we have more b's in the numerator. How many more? Well, there's a little 1 right here, and 2 minus 1 is 1, so I have a b to the first right there. So 3b all over 4a squared. So a little bit of multiplying here and simplifying. Has a stop sign here, because the first thing you should check out is, what are we doing? Well, we're dividing. Well, a division problem is just multiplying by the reciprocal. So it's going to be 4x squared y, 15 a cubed b cubed, times flipping what we're dividing by, 5ab cubed all over 2x y squared. Now, multiply numerators, multiply denominators, but before you do that, maybe you can simplify it a little bit. 2 goes into 2 once, it goes into 4 twice, so I can reduce there. Simplifying the 5 and the 15 here, 5 goes in there 3 times, 5 goes in there once. You could also do the same thing with the variables, but it's easier when you're just working with one fraction, so I'd do that first. 2 times 1 is 2. I have an x squared y and an ab cubed. Trying to keep it in alphabetical order, that'd be ab cubed x squared y all over. 3 times 1, right here, is 3. A cubed b cubed, and finally xy squared. The 2/3, your coefficients, the numbers in front, I can't reduce that anymore. Sometimes you can. So it stays 2 over 3. Where do I have more a's? I have more a's in the denominator. I have 2 more a's in the denominator. So this is a to the first right here if there is no exponent. So that's 3 minus 1, or a squared. I have b cubed over b cubed. If you subtract those exponents, it's 0. Anything to the 0 power is 1. So that just cancels out to 1. X squared up here, x to the first right here. The higher power is in the numerator, so you're going to have an x to the first up there, 2 minus 1. And then y to the first, y squared. More y's down here. 2 minus 1 is 1, so that's just a y. So cleaning it up a little bit, I'm going to end up with 2x all over 3a squared y. What are we doing here? I have 2 ratios, a rational expression here. I'm multiplying. So I'm going to reduce if I can. I seem to have a theme here with the 5s. 5 goes in there once, 5 goes in there 3 times. Simplifying the 8 and the 12, 4 goes in here twice, 4 goes in here 3 times. And then I multiply across. 2 times 3 is 6. We have an m squared. Now I have an n times an n. Adding exponents, that's n squared, and an r all over. 1 times 3 is 3. M cubed n squared r squared. So, the 6 and the 3, I can reduce that. You probably could have reduced it right away. 3 divided by 3 is 1, but whatever. 6 over 3 is the same as 2 over 1, so I'll just write it as 2 over 1 for right now. Where do I have more m's? In the denominator. How many more? Subtract your exponents. You have one more, so that's m to the first, or just m. N squared and n squared. They cancel out to 1. R over r squared, I have more r's in the denominator. So cleaning it up, and my final answer would be 2 over 1, or just 2, all over mr. 2 over mr, very good. Stop, collaborate, and listen. What do we got here? Division. So I can't factor anything because it's all of these are one term over one term. Okay, monomials. You don't really factor till you get into working with binomials. So, being its division, I'm going to rewrite it as a multiplication problem, but multiplying by the reciprocal. So nothing changes there. Times 10xy in the numerator, 9b in the denominator. So, reduce or simplify if you can. Well, 9 goes in here once, 9 goes in here twice. That cleans it up quite a bit. 5 goes into 10 twice, goes into 25 5 times. Now I'm just working with 2 times 2 or 4. And I have AB xy. AB times, oh, AB squared, sorry, times xy. AB squared xy all over 5 times 1, 5. What do we got? B, there's no a in the denominator, but b, x squared y squared. X squared y cubed, sorry. Okay, 4/5. I cannot reduce. There is no a in the denominator, so it's going to stay 4a over 5 for right now. There's more b's in the numerator, so I take 2 minus the 1 down here. It gives me 1, or b to the first, in the numerator. More x's in the denominator. How many more? 1. It'd be 2 minus the 1, or x to the first, left down here. Y to the first, y cubed. There's more y's down here. 3 minus 1 is 2. So we keep a y squared in the denominator. So 4ab all over 5x y squared. If you're understanding this, you can skip to number 7 if you want. I'm going to go over 5 and 6 right now, but feel free to skip ahead if you aren't having any questions. Once again, we're not going to factor anything. What am I doing here? I'm multiplying these two rational expressions, these two ratios. So I can start reducing right now, or simplifying if I want. 8 goes into 8 once, goes into 16 twice, and 9 goes into 9 once, and goes into 27 3 times. So our coefficients, the number in front of our variable terms, we can get going on. 1 times 1 is 1. I'll go a squared b right here times m squared n cubed all over. The 2 times the 3 for my coefficient. 6 a b to the 4th m to the 5th n. And then from here, reduce what you can. The 1/6, nothing changes there. I have more a's in the numerator, 1 more, so an a to the 1st. B over b to the 4th. We have 4 b's here, we have 1 b down here. Multiplying 4 b's down here, so it's 4 minus the 1, I get b cubed down here. M squared over m to the 5th. 5 minus the 2 is going going to give me an m cubed. That m cubed is going to be in the denominator. And then finally, n to the, well, 3 minus 1 is 2, so that's n squared. So rewriting this, an squared over 6 b cubed m cubed. Okay. First of all, what are we doing? Adding, subtracting, multiplying, or dividing? We are dividing. When you divide two rational expressions or two ratios, you actually multiply by the reciprocal. 14p q squared, 15w to the 7th, z to the 3rd, times now, moving this up to the denominator, or numerator, 35w cubed z to the 8th over 21p cubed q. Okay, let's simplify this a little bit beforehand. Definitely 14 and 21 are both divisible by 7. 2, 3, 35 and 15 are divisible by 5, so 3, 7. And then multiply across. 2 times 7 is 14. P cubed squared, pq squared, w to the 3rd, z to the 8th, all over 9. Let's put alphabetical order here. pq, that's p cubed q, w to the 7th, z to the 3rd. I always draw my z's with a little line through them so you know it's not a 2. Anyway, 14 and 9 do not reduce. Where do we have more p's? There's a 1p up here. There's a p cubed down here. 3 minus 1 is 2, so I have a p squared. Q squared, q to the 1st. I'm going to have a q left in the numerator, 2 minus 1. W. Okay, 7 minus 3 is 4. Where's w to the 4th? Well, you're multiplying more w's down here, so that's a w to the 4th down here. 8 minus 3 is 5, so that's z to the 5th, and z to the 5th right there. And there's our answer. Okay, that's into the first page. If you have any questions, put a question mark wherever you have a question, circle it, write any questions you may have down, and we'll go over them. I can help you out with them tomorrow in class. Okay, a little factoring review, because we're going to, when we start multiplying and dividing by binomials and trinomials instead of monomials, you want to factor ahead of time. This first factoring problem, there's 3 terms here. This is a general trinomial. You should check all 3 terms. Can I take anything out of all 3 terms? The only thing I can take out of all 3 of them is 1. Factoring this, well, being this a general trinomial, it's just 1x squared, so it's x and x. Now I need factors of negative 12 that add up to negative 4. Well, that's factors of 12 are 6 and 2. It'd be a negative 6 and a positive 2. They add up to the negative 4, but when I multiply them, I get negative 12. So it's x minus 6 and x plus 2. Those are my 2 factors. So I went from a trinomial, a general trinomial, to multiplying 2 binomials. This one, same thing. Look at all 3 terms. I can't take anything out but 1, so I'm going to go right into x and x. Factors of 2. This one's pretty easy, that add up to 3. There's only 2 factors of 2, 1 and 2. Or negative 1 and negative 2, but meaning we want a positive 2 when we multiply them. They both have to be positive when we add them to get a positive 3. So x plus 1 and x plus 2. Okay. Look at your terms. There's only 2 terms here, so it's not a general trinomial. But you always see if you can factor out a common factor out of both of them. 4 and 12, I can take out a 4, first of all. X cubed, x squared. The smallest power is 2, so I can at least take an x squared out of both of them. What do I have left in my binomial? Because there's 2 terms here, so I have 2 terms in the parentheses. 4x squared times x is 4x cubed, and 4x squared times just 3. 4 times 3 is this 12 right here, and then we already have an x squared. So once you do your greatest common factor, you should be able to multiply it back and get the binomial or trinomial you started out with. Anyway, that is completely factored right there. The x plus 3, sometimes you can factor it again. In this case, no. So, here we go. Simplifying rational expressions. I have two ratios here. I have a trinomial over a trinomial to begin with, right here, and I'm multiplying it by a binomial over a binomial. Anyway, looking at these two, when we our keys to success here, just factor everything you can. So we're going to do that. I'm going to factor this trinomial on top, and you'll see why we're going to factor it in a second here. Factors of -8 that add up to 2. Well, it's 4 and 2, but which one's negative? Well, it'd have to be a -2. 4 times -2 is -8, but when I add them up, I get +2. So that's x plus 4 and x minus 2. That's this first trinomial on top in our numerator. Our denominator, we'll put right here, x and x, factors of 3 that add up to 4. Well, that's add up to 4. That's 1 and 3. 1 times 3 is 3, and 1 plus 3 is 4. So it's x plus 1 and x plus 3 times, okay, this other side. Can I factor this numerator out first of all? Both terms have a 3. I can factor out greatest common factor, a 3 out of both of them. I'm left with x plus 1. That's what this numerator is. The denominator is x minus 2. I don't have any factors in common there, plus it's just x. It's kind of a key that you might not be able to factor unless there's a common factor in both of them. So I'm just going to leave that as x minus 2. Now simplifying this just means we're going to cancel out any factors from numerator to denominator. Like I have an x plus 1 in this numerator. That'll cancel out with this x plus 1 in the denominator. What else? I have an x minus 2 in this denominator. This would cancel out with this x minus 2 right here. Nothing else cancels out, so then you multiply straight across. I have a 3, just that number 3, one term, times this binomial over here, 2 terms, is x plus 4. That's what I have in the numerator. The only thing I have left in the denominator is an x plus 3. And that's our answer. You could simplify this and distribute the 3 through there and get 3x plus 12, but when we're multiplying and dividing these rational expressions, and even adding and subtracting them, a lot of times we'll leave your answer factored, just so you know that there's nothing that'll cancel out. Now, we could have, let's see if I can get rid of some of this green. You could have multiplied this across right away. Multiplying this numerator times this numerator. You're just going to end up with, we'll put this first, just the single term, 3 first, times x plus 4, times x minus 2, times this x plus 1 right here. This denominator times this denominator, x plus 1 times x plus 3 and x minus 2. But you would still have to cancel out any common factors. So you'd still cancel out the x minus 2's, you'd still cancel out the x plus 1's. You're still going to be left with the 3 times x plus 4 all over x plus 3. So that's why we cancel them out right away after we get everything factored, and then just multiply across and leave our answer in factored form. This is what you do when you have more than one term over one term. This is what you do when you have binomials and trinomials that you're working with. Factor Simplify by canceling out any common factors, numerator to denominator, and then multiply straight across and you have your answer. Being careful if you're multiplying or dividing. Okay, number 11 here. We are dividing. We're going to factor everything if we can to make the problem a little bit easier. X plus 2, it's x to the first power. There's no common factors, so I can't factor that. X plus 3, can't factor that out either. Times, this is a division problem, so I'm going to factor and flip this at the same time. So this is going to become my numerator now, this x squared minus 9. 9 is a perfect square, and so is x squared. So this factors 2, x and x, plus 3 and minus 3. If you were to FOIL this back out, you get x squared minus 9. When you multiply the x and the negative 3 and the 3 and the positive x, you get 3x and negative 3x, they cancel out. That's why it factors into this form with, it's called difference of perfect squares. This is going to go on the denominator when I factor it. It should be pretty simple. It's a straight up general trinomial, x and x. Factors of negative 12 that add up to 1. Well, we're working with 4 and 3 obviously. But which one's negative? Well, I want to get a positive one when I add them, so it's going to be a negative 3. So x plus 4, x minus 3. And then you just look and see where you can reduce it. Numerator to denominator. Now, in the numerator I have an x plus 3, denominator x plus 3. They cancel each other out. Some people aren't sure when they're in the same ratio or same fraction, but yeah, these two cancel out. One's in the numerator, one's in the denominator. They cancel out to 1. The only thing I have left when I multiply straight across is an x plus 2 all over an x plus 4. Now, here's a common mistake. Some people say, hey, 2 and the 4, I can reduce that. Not when you have two terms. That 2 is connected to the x in the numerator. This 4 is connected to the x in the denominator, so I can't just cancel out the 2 and the 4. The only thing I cancel this 2 out with is if I had an x plus 2 over an x plus 2. Then the binomial itself would cancel out. So you can't just pull a binomial apart and start canceling it out with other numbers. Likewise with the x's here. I can't just cancel these x's out because this x in the numerator is part of the binomial x plus 2. I can't just take it away from it. So there's our answer. Multiplying here, just got to make sure we factor everything when we're working with more than one term. Y minus 1, no common factors. 5y plus 15, I have a common factor of 5, so I'm going to factor that 5 out. I'm left with y plus 3. Times. It's multiplication, so I don't have to flip anything. Factors of 6. Factors of 6 that add up to 5. I think it's y and y. Plus 2 and plus 3. 3 times 2 is the 6, and 3 plus 2 is the 5y in the middle there. All over. Factors of negative 5 now for this bottom trinomial in the denominator here that add up to 4. Well, that's 5 and 1. It looks like it's a negative 1. 5 times negative 1 is my negative 5. 5 plus negative 1 is my positive 4. So y plus 5, y minus 1. Okay. Then, are there any factors that cancel out? Numerator to denominator. Well, the y minus 1s will cancel out. Y plus 3s, and that's it. Y plus 2 is the only thing you have left in your numerator. All over. Don't forget your numbers, your single terms. 5 times y plus 5 right here. And there's our answer. Okay, next one. number 13 here. It is a division problem, so we're going to have to multiply by the reciprocal. And we can factor this numerator here. Factors a negative 35 that add up to 2. Well, it's 5 and 7. I want a positive 2, so it's going to be positive 7 and negative 5. If I FOIL this back out, I'll get the x squared plus 2x minus 35 all over. Some people struggle with this. 4 is a perfect square. X squared is a perfect square. Okay? If I took the square root of x squared, I'd get x. X times x is x squared. If I took the square root of 4, that's 2 and 2. So x plus 2, x minus 2. That's one way to work with difference of perfect squares. Times, it doesn't look like either one of these factor. So numerator goes up, x plus 2. Denominator comes down, multiply by the reciprocal, x minus 5. So, canceling out, simplifying here. These cancel out to 1. X plus 2 is simplified down to 1. And I'm left with x plus 7 over x minus 2. Very good. And this one here? Oh, that was 13. Good. Okay, complex fractions. They sound complex or complicated. They're really not that bad. Complex fraction is basically a fraction within a fraction. This is an example of a complex fraction. You have the fraction x minus or x divided by 3 in the numerator, and here, down here we have x all over x squared plus 1. You have to find the main fraction bar first, and here it is. This is just a different way of writing x over 3 divided by, that fraction bar is just division, x over x squared plus 1. So what do we do when we have a problem like this? Well, you change division to multiplication, you multiply by the reciprocal. So we're going to multiply by the reciprocal of the denominator here. That's all we're going to do. So this becomes x plus 3, flipping this up and multiplying by its reciprocal, x squared plus 1 over x. The x's do cancel out. I can reduce that. I'm left with x squared plus 1 all over 3 in this case. So when we're working with complex fractions, you basically you can set it up like this if it makes more sense to you. Then you know you're multiplying by the reciprocal, but you're basically just going to take the numerator and multiply it by the reciprocal of the denominator. That's what you do with complex fractions. So it's just a different way of writing a division problem. Yeah, we got a rational expression in the numerator. We got a rational expression in the denominator. Here's my division bar, my main division bar. So all I'm really doing is taking that fraction on top and multiplying it by the reciprocal of this denominator. So the x minus 5y goes on top and the x goes on the bottom. And then you factor where you can. This problem is a little bit more complex, and working with, I can't factor x squared, it's just one term, or this x. I can't factor x minus 5y, they have nothing in common and it's not any perfect squares. This doesn't look like you can factor it, but you can. X squared is a perfect square, so is 25, so is y squared. So it's x squared all over. Okay. The x squared is pretty self-explanatory. That's x and x. To get this negative 25, it'd be negative 5 and positive 5, but the y squared with it, it's going to be y and y. So minus 5y and plus 5y. Look, if you FOIL this and multiply these, you get negative 25y squared, this term right here. The product of the outside and the inside terms, you're going to get, looks like 5xy and negative 5xy. They would cancel out, hence working with the difference of perfect squares here. Get rid of this now. Times x minus 5y all over x. Okay, so these cancel out. You could multiply across here, but in fact, I think I'm gonna have an x squared all over, have one term right there, x times x plus 5y. Now, this x squared is attached to nothing. This x we're multiplying by the x plus 5y, but I can reduce the two x's here. If it's just multiplication, you can reduce it. I can't reduce it with this x because it's connected to the plus 5y as an addition problem. But if it's multiplication, you can reduce it. Where do I have more x's? In the numerator. So I'm going to end up with 2 minus the 1 and get x in the numerator and x plus 5y. You could also have done it here, being this is in the numerator and this is in the denominator. This is an x to the first, this is an x squared. I have more x's in the numerator. You could say this cancels out to 1, but this cancels out to just x, or reduces down to x. And if you multiply across, you're still going to get the x over the x plus 5y. So a couple different ways to do that. You can reduce it right away, simplify it, or multiply it across and then reduce it. We have another one here. It's a complex fraction. Okay, so I'm going to rewrite this. My numerator. X plus 3 squared is actually x plus 3 times x plus 3. And x squared minus 16, you should know now that's difference of perfect squares. So x and x for the x squared. 16 is 4 times 4, so I need a negative 4 and a positive 4. So when I multiply them, I do get the negative 16 times. Okay, this is what we're dividing by right here. So I got to multiply by its reciprocal. So it becomes x plus 4 all over x plus 3. Okay, can I simplify this? Well, the x plus 3, numerator to denominator, cancel out, and an x plus 4. Multiplying across, I'm left with x plus 3 all over an x minus 4. And we're done. That is simplified. Okay, a little word problem here. A parallelogram with an area of 6x squared minus 7x minus 5 square inches has a base of 3x minus 5 inches. Determine the height of the parallelogram. So this is what we're trying to find, is height. Area of parallelogram is base times height. Well, what do we want to find here? We want to find the height of the parallelogram. One way I could do that is divide both sides by base. The height of a parallelogram is area divided by the base. So if I set this problem up, area divided by base, I can find the height. Area is 6x squared minus 7x minus 5 all over 3x minus 5. Now nothing cancels out here yet. You should be able to factor this, hopefully, this numerator. The denominator 3x minus 5, it has nothing in common. The numerator is a general trinomial, but we have a 6x squared here. So you can do guess and check, or you can use the box method. I guess I'll try guess and check first. I'm guessing, well, the factors of 6 are 1 and 6, and 2 and 3. I'm assuming it's going to be 2x and 3x. But it could be x and 6x. There's not a lot of factors of 5, 1, and 5. One of those has to be negative, and I have to add up to get -7. I'm going to put the 5 here, and I'm going to put the 1 here. Now, I get a 10x right here, and the inside I get a 3x. The difference is 7, but which one has to be positive? Looks like the 3x has to be positive because we want -10 plus 3 is -7. So it does factor. 3x minus 5. Okay. Oh, which one was negative again? Shoot. I think it was -5 and a positive 1. That'll give me 3x, -10x. Yeah, that'll work. So once we factor it, we can see that the 3x minus 5's will cancel out. So that means my height has to be 2x plus 1 inches. 2x plus 1 inches. I guess the box method, when you're doing that box method, you can put the 6x squared in right away and the -5. The two other squares, you're going to add up to get -7, but what are you actually adding up? Well, being it's 6x squared, you got to multiply 6 times -5 and get -30, sorry, and adds up to -7. Well, that was 10 and 3, and it'd be -10. So we'll say -10x and positive 3x are the two terms you put in there. And then just greatest common factors in the top row and the bottom row. First of all, this top row right here, it looks like I can take out a 2x. Bottom row looks like, well, just a 1. So one of my factors is 2x plus 1 times. Going columns now, the first column going up and down, I have 3 and 6, so I can take out a 3x there. They're both negative, so I can take out a negative, and it looks like just a 5. 3x minus 5, and that's the same thing we got up here when we did guess and check. So I showed you both methods, whichever one works best for you is great. You're working on your worksheet. If you do have any questions on this, make sure you circle a question mark or highlighter or something like that. Write the question down in words that you have, so when you get to me tomorrow, you can ask that question easily. Peace out, Girl Scout.